In this video, we will create a custom component for a polarization splitter with the SciFi PDK. It will be implemented in this transceiver circuit. For our component, we will use the geometry obtained from this cited research paper. Inside this PSR, there are two components where a mode conversion occurs: the bilevel taper and the adiabatic coupler. Let's start with designing the bilevel taper. The bilevel taper realizes a TM0 to TE1 mode conversion. To create this component, we define a parametric cell, or a PCell, and draw the layout in its generate elements method. Afterwards, we can visualize the layout in different ways. After finishing the layout, we can simulate our component with our integrated link with Lumerical MODE. If we now run our code, we will go inside the third-party tool and see our converter. As everything is set inside IPGIS, we don't need to change anything inside this tool. We can visualize the mode propagation for a TE0 input and TM0 input and plot the transmission curves. Now let's have a look at the next component. The adiabatic coupler has the geometry of an asymmetric directional coupler. In this coupler, a TE1 to TE0 mode conversion occurs. Both outputs of the coupler end up with a TE0 mode. Once the simulation is finished, we can add the resulting components to our IP library, where we can maintain and reuse it in a clean and structured way. In our case, we have created a structured folder of the asymmetric directional coupler in which you can find the PCell, simulation recipe, examples, and simulation data. We follow the same approach for our first mode converter, making it easy to integrate this PCell to create a full PSR. Once we have created the PSR, we can easily integrate it in a larger circuit. Really easy to do. Thanks for watching.